ꯑꯩꯒꯤ ꯚꯤꯗꯤꯑꯣꯒꯤ ꯁꯦꯔꯤꯁ ꯑꯁꯤꯗ ꯑꯩꯅ ꯀꯥꯎꯟꯁꯤꯜ ꯑꯣꯐ ꯍꯥꯌꯔ ꯁꯦꯀꯦꯟꯗꯔꯤ ꯏꯗꯨꯀꯦꯁꯟ ꯃꯅꯤꯄꯨꯔꯅ ꯁꯤꯟꯕ ꯀ꯭ꯂꯥꯁ 12ꯀꯤ ꯆꯍꯤ ꯈꯨꯗꯤꯡꯃꯛꯀꯤ ꯁꯤꯟꯕ ꯑꯦꯛꯖꯥꯃꯤꯅꯦꯁꯟ ꯍꯥꯌꯔ ꯁꯦꯀꯦꯟꯗꯔꯤ ꯑꯦꯛꯖꯥꯃꯤꯅꯦꯁꯟ ꯈꯨꯗꯤꯡꯃꯛꯀꯤ ꯄ꯭ꯔꯤꯚꯤꯌꯁ ꯏꯌꯔ ꯈꯨꯗꯤꯡꯃꯛꯀꯤ ꯀꯣꯏꯁꯟꯁꯤꯡ ꯑꯗꯨꯒꯤ ꯁꯣꯂꯨꯁꯟ ꯑꯗꯨ ꯚꯤꯗꯤꯑꯣ ꯑꯁꯤꯗ ꯑꯩꯅ ꯁꯦꯝꯖꯔꯤ ꯃꯌꯥꯝꯅ ꯃꯁꯤ ꯃꯤꯠꯌꯦꯡ ꯇꯥꯕꯤꯌꯨ ꯑꯗꯨꯒ ꯃꯁꯤꯒꯤ ꯑꯐ ꯐꯠꯇ ꯑꯗꯨꯒꯤ ꯗꯥꯏꯇ ꯑꯗꯨꯗꯤ ꯑꯩꯅ ꯂꯧꯖꯒꯅꯤ ꯍꯥꯌꯔ ꯁꯦꯀꯦꯟꯗꯔꯤ ꯑꯦꯛꯖꯥꯃꯤꯅꯦꯁꯟ 2010 ꯍꯥꯏꯔꯤꯕ ꯆꯍꯤꯁꯤꯗ ꯍꯪꯈꯤꯕ ꯄ꯭ꯔꯤꯚꯤꯌꯁ ꯏꯌꯔ ꯀꯣꯏꯁꯟ ꯄꯨꯝꯅꯃꯛꯀꯤ ꯀꯣꯏꯁꯟꯁꯤꯡ ꯑꯗꯨ ꯋꯤꯠ ꯑꯟꯁꯔꯒ ꯂꯣꯏꯅꯅ ꯅꯩꯅꯁꯤ Mathematics full marks to 100 pass mark 33 time 3 hours 15 minutes 15 minutes are given as extra time for reading questions minute 35 amadi question pananabagidamaktha piba ahenba matamni 3 hours asidana ibagi process answering gi matam oigani all questions are compulsory matamdugi syllabus ta leiba question aduni ahanba wahang define a differential equation what are its general and a particular solutions differential equation ama haibasi karina mahaki general solution haibasi su karina particular solution haibasi su karina mark ahum differential equation ahanbada differential equation haibasi define tausi masak taksi an equation involving derivative or derivatives of the dependent variable with respect to independent variable of variables is called a differential equation. Dependent variable da independent variable natraga variables singna derivative lowbagi derivative sing natraga derivative yauba equation amabu differential equation kawi samna derivative natraga derivative sing yauba equation amabu differential equation kawgani mafam asida koina independent variable or variables haibagi maramdi function amada variable independent variable ani degi henna leiba yai aduguma matam adudadi aikoina atopa higher studies ta differential equation ge makhal ani leigani ani degi manungda amana ordinary differential equation independent variable ama khaktang yauba aduga independent variable ani natraga ani degi henba yauba adugumba differential equation adubuna partial differential equation kawi matam aduda aikoina definition asina differential equation asigi definition asina partial differential equation gi adusu yauna define tawre but hauji aikoina nainagadoriba asidi ordinary differential equation ni independent variable ama kakang yaubane aikoina nainagadoriba si general solution what is the general solution of a differential equation maming asina su taksare generalize oba answering ama aikoina pidori solutions amada a solution of a differential equation is said to be a general solution of the equation if the number of arbitrary constants is equal to the order of the equation. Differential equation amagi karigumba solution amana general solution haigani general solution adu the yauriba solution adu the yauriba arbitrary constant masinga differential equation adugi order masinga chap manarabadi madugi solution amabu karigumba solution amabu differential equation adugi general solution kaugani ahanbada solution ado differential equation gi solution di oigadabani aduga solution adu the yauriba arbitrary constant masingduga differential equation adugi order masinga manarabadi solution ado general solution kaugani next particular solution what is the particular solution of a differential equation a solution of a differential equation is said to be a particular solution of the equation if the solution is obtained from its general solution by giving particular values to the arbitrary constant. Karigumba differential equation amagi solution ama asi particular solution kaugani solution adu general solution da yauba particular arbitrary constants sing da particular values sing piraga phangba oirabadi differential equation adugi solution ado differential equation adugi particular solution kaugani samna hairabada particular solution haibasidi arbitrary constants yauroi loinena piramiba differential equation adugi solution oigadabani next question number 2 let a equal to n cross n there is n by n a haibas set asi Cartesian product of two sets ni where n is the set of natural numbers and asterisk be a binary operation on the set A defined by AB asterisk CD equal to A plus C, comma B plus D. Asumana define tore. show that asterisk is commutative and associative. Ahanbada asterisk asi commutative ulu lonena associative su. Find the identity element for asterisk if it exists. Binary operation asterisk ki identity element lairabadi madusu putho amu mark ahum. Here a b asterisk cd equal to a plus c comma b plus d. Hariba definition asi aikoide define torame wahang asida hauzik commutative oi utninabagi damaktadi ani sub step ta also cd asterisk ab asi aikoina amuk define toksi piramiba definition asi gi matuna first ka third ga ani se first ka third ga ani se sum up torasi second ga fourth ga ani se sum torasi that is b plus b. A C plus A haibasidi A plus C ga manai maramdi natural number sing asi commutative property holds zumi aduna hana kon onthokna raga tinjana bi C plus A gi mahuta A plus C bi D plus B gi mahuta B plus D bi hauzik left leriba han pyramid ba asigi right asiga ani suba aikoina puthokliba asiga right ani si manarabadi left ani si manare left ani so AB asterisk CD equal to CD asterisk AB. Haibadi asterisk ki both side lariba order pair and is interchange taunarabasu full chap manare masibuni aikoina commutative haribasi. Thus asterisk the binary operation asterisk is commutative. Next associative. Again AB asterisk CD asterisk EF bracket manungda lariba order pair ani sigi definition adu ahanba wahang the piramba definition adu panjalasi AB order pair di lengdana thamsi asterisk C ga E ga ahan bata tinjnaro C plus E comma D ga A ko tinjnaro D plus F hana swai kre C plus E haibasi ga amuk A ga ahan ba anisi amuk sum up torosi ahan piramba definitions amuk hana seasonarasi that is A plus of C plus E comma B plus of D plus F madubo aina A plus C plus E haina ire B plus D plus F haina ire. Similarly, AB asterisk CD order pair asi hana pangthoklasi ahanba order pair ani si hana definition do pangthosi EF na tonga na thamasi ahanba ani samdi AC plus B ga D ga di B di lerani aduga EF to D remains unchanged amuk definition do ado amuk hana palasi A plus C of E phangani mathangda B plus D of F phangani hauzik right leriba x order pair ani si sap manare maram masina left leriba expression ani si manarani thus asterisk is associative haibadi order pair ahum grouping to matamda different ways to grouping to rabasu full chap manai masibuni aikoina associative haribasi thus binary operation asterisk is associative. Second part identity element lairabadi putu u haibani let mafam asidadi A ase koina E dash on logani let E dash be the identity element of asterisk then A B asterisk E dash equal to E dash asterisk AB equal to AB. This is the by definition of identity element. Identity element ke matung inadi aikoina order pair singda khangkhre mamangda E haibasi order pair oirabadi A hariba any element siga E ga asumna E na amuk halaga asterisk A haibasi khudingmak A tagadabani mafam asida A si akaknaba number kharna chumbe yade set adudi yawba number khudingmak na chumgadaba condition na chit chumlabadi maduba ikoina identity elements lay haigani asugumba element E puthokpa ngamlabadi mafam asida E asi E dash ni A asigi mahut asina A comma B order pair on logani person yawba N asi mahaki single number ni adubu A asidi order pair on logani then ahanba A B E dash ani si pangthoklasi hojik A ga E ga amuk sum up toro B ga E dash ka ani si sum toro definition first most ki definition do policy aduga left right most asi lengdana thamasi marakki asi koina seasonal su yai adubu koina data is sufficient adon apamba khalaga loni first ka last ka lore hojik order pair ni manabagi definition policy when are two order pairs said to be equal when are two order pairs said to be equal order pair ani karma matamda managani haiba order pair ani manabagi definition do palabadi A equal to C phange and B equal to D phange mafam asida A asi kanano A plus E na oirani aduga C asina kana oigani C A asi oigani hariba definition asi panjillabadi a plus e equal to a orani second ga ani si manarani hojik masidiki aikoina e solve torabdi a kakthana khrabadi e equal to 0 fange aduga b kakthakarasu e dash adu 0 fange adudi e su 0 lere e dash ki su 0 lere does not contain in a maramdi 0 haibasi natural number oigadabani 0 haibasi natural number a haibasi n by n haibani n haibadi natural number singakto oigadabani अदुगो मसीदी 0 दी नेचुरल नंबर नत्रबनिना 0 order pair asi a di yaudde maramdi 0 is not an element of n the set of natural numbers adudi identity element lairabadi puto haibani adudi last conclusion di hence there is no identity element for binary operation asterisk hariba binary operation asigi identity element laite hence the result followed. Next question number 3. Prove that the value of this determinant is 1 plus a square plus b square whole power 3, which is also 3 marks 2010 ni matamni. Let us define, let us prove 1 plus a square plus b square si ahum lak phanggadabane ahan beda ama phangnana bhona si loinana maximum 0 su phangnana ba sin si lairiba maw mataw se akoina munni yengani sida plus lairam labadi 1 factor phanggadabane aduna hoji 0 masing tam yamna phangnana ba loinana 1 plus a square plus b square phangnana ba sin si khara maw mataw si khara munni yengba changi hoji third row asida row do pangthok pa yai maram di symmetric oibanina row do pangthok asu yai column wise pangthok asu yai hoji yengsi sigi third row asida aikoina b na puri silaga first row da hapchil labadi first row gi sigi new element adu 1 plus a square plus b square phangani lonena sida b na puri silaga twice a b da hapchil labadi 0 su phangi adu di apamba factor su phangi 0 su phangi lonena sida b na puri silaga sida hapchil labadi sum up torabadi we get apamba factor ama phangba yai let's see yengse hoji row 1 asida row 1 plus b times row number 3 new row 1 asi hanagi row 1 asida b times of hanagi row 3 to hapchen ba matam ba si phangani loina na 0 masing yamna phangna ba second row se third row asida a na puriraga second han all second row asidagi b times of all third row khaidokhrabadi sigi new places to 0 phangi loina na lemhori ba element ani asi so apamba factor singdo phangi hozik third row adudi lengdana thamani pangthokiba operation adu nakanda sumna notation asi sijinarani kaidore hozik first row dagi apamba factor ama lokthokpa yare second row dagi apamba factor ama lokthokpa yare factor ani mak chap panarabanina kamal lokthokpa matamda factor ama square tarasi 1 plus a square plus b square first row dagi lokthokadi new first row do 1 0 minus b leoni second row dagi 1 plus a square plus b square lokthokrabadi new second row do 0 1 a lehorani third row adudi lengdana thamasi hozik si phangai mathangda 0 amaga row amada natraka column amada 0 ani phangna bu kona si property sing palaga determining gi property sing palaga first column da sigi first column da b na puriraga third column da hapchil su sigi new places to 0 phangi adom pangthok pi ai ado koi makha zatharasi third column asida all third column asida b times of hanagi first column as hapchil sigi new places to 0 lare first column second column hanagi column ani du lengdana thamo third row du di sig operation si matung si phangane hauzik 0 masing yamna yaure new first row 0 masing yamna yaure masig first row si the determinant si expand toksi 1 do thamo mahak yawbo row ga mahak yawbo column ga minor di mahak ki proper sign cofactor ki proper sign di plus ni mahak yawbo row siga mahak yawbo row siga mahak yawbo column siga kakthakhrabadi si kakthakhrabadi siga purinari we get this asima phangani minus times of siga purinari minus or minus the plus twice ab phangani asumna manung si factorize torobadi minus a square ga plus twice a square ga di a square phangani adu manaba factor han square ama karame amaga amuk hapsilabadi cube lare hence proof. Question number 4. If theta is the angle between two lines OP and OQ with direction cosines L1, M1, N1 and L2, M2, N2, find cos theta and sin theta. Theta haibasi OP amasung OQ haiba direction cosine singna L1, M1, N1 and L2 M2 N2 oiba adugumba line anigi marak angle ni adugum find cos theta amsung sin theta puthu u haibani wahang asi mark ahum ni mark ahum ga chana na khungbani aikoina mark ki matung na khungbani mark amatang ani jang piram lagadi magi statement singdu iramaga lore but mark ahum yokhulabani na kitang geometrical construction khare yawraga khumna bohonasi. Let E1 cap and E2 cap be two unit vectors along OP and OQ. Ayekpa picture sida sigi OP hariba vector sigi maikede zatpa unit vector amani E1 cap hariba sina E2 hariba sina E2 OQ sigi maikede zatpa unit vector ni maraki angle da aikone theta loksele maraki angle da theta loksele. Then E1 cap have a say E1 cap have a unit vector say E1 की माइके डिसाइड पा vector मासी unit vector ओइरबनिना OP की direction cosine अदुदा IJ के ने respectively पूरी नगने असुमना E2 असिसु OQ की माइके डिसाइड पे unit vector ni लोने ना OQ की माइके डिसाइड पे OQ की direction cosine सिंगा सीधा respectively I cap J cap के ना पूरी का फोंगो कनी मसी मागी चटनबिनी डायरेक्शन कोसाइन की unit vector की ijk की mamang da leiba number singa do direction cosine oigadabani. Now cos theta vector scalar product of two vectors parallel E1 cos theta haibasidi E1 cap dot E2 cap ni unit vector ani sigi scalar product ki L1 L2 plus M1 M2 plus N1 N2 oirani the ahan but result to fange prove tore. Next also we have cross product of two vectors E1 vector E1 cap into E2 cap with the sin theta n cap into E1 cap modulus of E2 cap ni unit vector ki modulus ni 1 oirabani na assume n cap sin theta equal to E1 masi karamba formula no koina cross product ki formula do mafam aside ige isi vector ani sigi cross product ki definition do ni mafam aside koina pali basi sin theta into n cap. Chidi unit vector mafam asida 1 1 oithokrani adu disilani. Vector ani ki cross product hi ekhone determinant form da ithokani determinant form da first row dana I cap j cap k cap irani second row dana E1 u cap ki direction cosine sing L1 M1 N1 sing adu irani asumna ani suba third row adadi ani suba vector ki direction cosine sing adu irani hauji koi first order expand tausi first order expand toroga si phangle after calculation da vector ani si makai ani makta khona comparing magnitudes we get both sides songi magnitude t sigi magnitude kaya oigani sin theta oirani maramdi unit vector sigi magnitude lobo matamda sigi magnitude lobo matamda sigi magnitude lobo matamda di sin theta kaktang lai horani aduga songi di I cap j cap k cap singi na mamang da lari ba scalar singa sigi square gi sum da root taking positive square root logani which gives the value of sin theta. Next question number 5. Find the value of lambda such that the scalar product of the vector this with the unit vector along the sum of the vector this and this is equal to 1. Vector ani sigi sum gi maikai de satpa sum gi maikai de satpa unit vector duga ahan ba piramba vector ani vector siga ani gi scalar product to gi scalar product to 1 tarabadi scalar product to 1 tarabadi lambda की value पुथु उ हाइबने मुक्तंग निंसिंगे आहान बे वेक्टर सिगा अनि सुबम सु अहुम सुब वेक्टर अनि की सम की माइकै दे सटपा यूनिट वेक्टर दुगा अनि की स्केलर प्रोडक्ट टू 1 ओइरबदी लैम्डा की value पुथु उ हाइबने let आहान बे वेक्टर सी ए वेक्टर न खंगना रसी अनि सुब वेक्टर सिन बी वेक्टर खंगना रसी अहुम सुब वेक्टर सिन सी वेक्टर हाइना थोलसी हौजिक b plus c हाना पुथोक्सी now b vector plus c vector d ani si scalar product vector ani si ki component singa si sum up toro I gina si phangani j gina si phangani k gina si phangani zik maha ki magnitude therefore unit vector along b vector plus c vector vector amagi maikari satpa unit vector puthoke hairabadi aikoina hana khangkhre a vector c gi maikari satpa unit vector puthoke hairabadi vector do maha ki magnitude na divide tagon hariba formula si mafam masita pale ꯑꯩꯈꯣꯏꯅ ꯃꯁꯤ ꯐꯪꯒꯅꯤ by question wahangna kari hare ahanba vector siga vector siga ani gi dot to 1 tagani haibani adudi hojik sigi modulus ti mathakta koina khangkare respective value sing pisilo a vector gi dc lairani b cd sida lairani ani dc scalar ni na somda by the cross to kro aduga lemhoriba scalar product of these two vector ni se I gi coefficient 1 ga sigi I gi coefficient 2 plus lambda ga purinero j की coefficient 1 ga c की j की coefficient 6 का पुरिनरो c की k की coefficient 1 ga c की k की coefficient -2 का पुरिनरो c की scalar c की right ta thangdokro hoji left si simplify toro squaring ka tho aduga hoji kon si phange mamu expand to tho obadi akon lambda की value do 1 phange do ko da value do sin question number 6 prove that the value of a third order determinant is 0 if two columns are identical. Third order determinant amagi column ani manarabadi determinant value 0 oigani pramanto. Let delta equal to this. First column the A1, A2, A3, second column adu B1, B2, B3, third column adu B1, B2, B3. Be a determinant in which the second and the third columns are identical. Second column ko third column ko manaba maung do lowre wahang asigi praman tongnanabagidama. Let delta 1 be the determinant obtained by interchanging the second and the third columns. Delta 1 haibisina delta dagi semba third column ko second column ba pham onthong na ko phangba determinant ama ni ana lowre. Then delta 1 becomes this. Masi which is same as delta masi delta ga chap manare. Maramaduna therefore delta 1 equal to delta. Right side asisu delta na replace tawre magi phangakadaba value to delta on loksele which is equation 1. The sign of a determinant changes if any two columns are interchanged. Karigumba determinant amagi column ani interchange sorabadi determinant adugi value do sign change tawgani haiba property ro palabadi delta 1 ase kanaga managani minus delta ga managani. Sign change habadi hanagi value gi determinant ado delta orabadi next delta 1 value se minus delta ga managani haibani. Therefore delta 1 equal to minus delta which is equation 2. Equation 1 amsung 2 dagi koina khange left ani si manare right ani si manarani. From 1 and 2 we get delta equal to minus delta. Do we get delta equal to 0? Delta equal to 0 column ani or column ani manarabadi determining value 0 we can have to prove tore. Hence the value of a determinant is 0 if any two columns are identical. Next question number 7. Prove that sin inverse of 3 by 5 plus cos inverse of 12 by 13 plus cot inverse of 56 by 33 equal to pi by 2, which is mark 4 in 2010. Left hand side, sin inverse of 3 by 5 plus cos inverse of 12 by 13 plus cot inverse of 56 by 33. Matamadu gi fangba formula gi matung in proof tawrage. Sin inverse of something have a set tan inverse kaya ga manabagi have a property masida pale. Sin inverse of x have a set tan inverse ta kaya ga manai have x by root over 1 minus x square ga manai. Amuksu cos inverse of x have a set tan inverse ta loina sad a tan inverse of root over 1 minus x square by x. Hariba property ani se palane hojiki oina. Then see properties of already this become this for this after simplify we get this two. The third term is the length and some putarani 10 inverse ani si tension si 10 inverse ani tension gi formula d 10 inverse x plus 10 inverse y gi formula palabadi 10 inverse of x plus y by 1 minus xy policy. Then 10 inverse ani si palabadi si phangani. Third term do the hojikti third term do length na thamo second term oire simplified tore 10 inverse ka converse ka ani cd famous result ama identity ama lay 10 inverse x plus cot inverse x to the pi by 2 ka mane hojik koina palabadi si phangane machine right hand side yaure hence proof which is mark 4 mark. We have used this one is also seasonary property marini adu mari. Question number 8. If x to the power y equal to e to the power x minus y, prove that dy by dx equal to log of x by 1 plus log x whole square, which is mark 4. X to the power y variable the variable na power kare siki khwaidagi chunaba technique logarithmic differentiation ni variable the variable na power ka basi di khwaidagi chunaba ponodi hena phaba atop technique su lay. Let's prove. Hozik both side log so let's say taking log on both sides we get this power kaba ma single log so labadi power that is x minus y log ki mamang le horani x le hore power kaba ma sinda log so labadi y to log ki mamang la ani log e have a city 1 ga mana have a koi khangre then sigi y mamang la ani y into log x la x minus y la ani log e di 1 ni ustagi ai koina y solve toksi transferring toroga. Now y is expressed in terms of x. Such type of function is called explicit function. Then we have to find out dy by dx. Taking logarithm on both sides with respect to x, we get for left we get dy by dx. And apply quotient rule on the right side. Denominator remains unchanged in the numerator at first. Into d by dx, and d by dx of x is 1 minus numerator x remains unchanged into derivative of denominator that is 1 plus log x ki derivative to 1 by x ni denominator whole square. After simplify we get this. This was to be proved. Then we get this. Question number 8. I ahan bedugi o ni sin alternative ni. If x equal to log t and y equal to 1 by t, prove that d square y by dx square plus dy by dx equal to 0, which is mark 4. X is expressed in terms of t, y is expressed in terms of t. Such type of function is called parametrically defined function, where this t is called parameter. We have to firstly find out dx by dt. Log t whose derivative with respect to t is 1 by t. 1 by t whose derivative with respect to t is minus 1 by t square. Therefore, dy by dx is using this formula dy by dt whole divided by dx by dt. Putting this and we get minus 1 by t. Next, we have to find out second order derivative, which is denoted by d by dx of dy by dx. dy by dx already found to be minus 1 by t. This is function of t, this is x. Therefore, we have to change this x into t. d by dt of this function and dt into dt by dx. Cancelling this dt, we get this. Now this minus 1 by t ki di 1 by t square learning dt by dx ki di 1 by of dx by dt to pala badi 1 by of 1 by t. Cancelling we get 1 by t. Now sigi left hand side asi thamasi second order derivative ki value di 1 by t ni dy by dx ki di matak to minus 1 by t ni kaktana rabadi 0 pangai. This is also proved. Question number 9. Solve the differential equation this 1 plus x square times of dy by dx plus y minus e to the power 10 inverse x equal to 0, given that y equal to 1 when x equal to 0, which is also 4 marks. Here this solving we get this. We have put the equation in linear differential equation. This is which is in the form of dy by dx plus p of y equal to q. Here q is what? This is function of x, and here what is p? This p is this. Therefore, this is a linear differential equation. This is a first order linear differential equation. Therefore, integrating factor whose formula is e to the power integral of this p dx. We get p is 1 by 1 plus, so whose integrand is 10 inverse x, e to the power 10 inverse x. The general solution is y into integrating factor equal to integrand of this factor into integrating factor dx plus c. Cancelling, multiplying these two, we get this. Next, put 10 inverse x equal to z, whose derivative is this. The z x na derivative or dz by dx number transfer to thokra, this is completely changed to z, whose integral is e to the power twice z by 2 plus c. The original value the e to the power z ti kaya ga mana kare z ti tan inverse x ka mana kare solution da si phange sini divide of thoga thamasu yare particular solution whatly when y but y is 1 when x is 0 it is given. Therefore putting these two values in the above general solution we get y the 1 pisilo x the 0 pisilo x the 0 pisilo we get plus c the c solve to over the half ki value the matak sinjala. The required solution is this. The half ki value the c ki value half the pisilo over the this is called particular solution. And bagisina general solution x among y की value set pair ama pirami karigi c की value puthokpa ngamnabagi damo madu puthoba matungda aikoina si phange masina magi particular solution ne aha beiten general solution china particular solution 1 mark ama general solution mark 3 ama 4 mark channel cross multiply 2 na both side multiply taradi sumaina by nature da thamdre. Question number 10. Find the shortest distance between the pair of lines whose Cartesian equations are this and this. Cartesian equations in a C over line any C gimarakta leva shortest distance put to 4 marks in 2010. The given equations of lines can be written in vector form as vector form the sumna EVI. First line adu asumna ithoni, second line su chamanana sumna ithoni. First line for the point number the sini mag ani suba line as a possible point number sini. This is called A1 and this is called B1. First line of the parallel oiba vector amani. Sina A2 lerani, sina A2 lerani, sina B2 lerani. Kari putokani B1 cross B2 puto B1 ga B2 ga cross for determinant from the ithoni expand roni and after simplification we get this. Similarly, C modulus log to C minus 1 square plus 2 square plus minus 1 square we get root over 6. Next A2 minus A1 putokani shortest distance ke formula da simus to change A2 dagi A1 khaido khadi C dagi C khaido khadi I phange 4j dagi twice j khaido khadi twice j 5k dagi 3k khaido khadi twice k. Shortest distance standard deviation of shortest distance whose formula is respective value simple C A2 minus A1 just above the pankre B1 cross B2 gisu mathak to lehore thame ma ki modulus te hana putho thamore scalar product ki I coefficient puinero simplify to 1 by root over 6 units pang. This is 4 marks. Question number 10. Oh, find the distance of the point 1 minus 2 3 from the plane x minus y plus z equal to 5 measure parallel to the line dash. Point ase plane asiga parallel oiba plane point asiga find the distance of this point from this plane heaven. Point asi plane asidagi oiba rapa putu arapa to karam ongani point asidagi perpendicular plane asta chingoi. Measure parallel to the line is apiba line asiga parallel oina singaba apiba line asiga parallel oina singba point asiga singba plane asiga unapam point adu garapa putu haibani. The equation of the line passing through the point is parallel to the line apiba line is this. Apiba line ga parallel of line sing the direction ratio sing proportionate oigani haibadi apiba putokada line se c orani sina c oigani. Mark 1 minus 2 1 minus of minus 2 minus 3 lerani. Then fraction kudumak r ga mana hale sidagi khoina si lere apiba point adu sini apiba plane adu sini ado point ase plane sara pa si ga perpendicular distance na te line si ga paring da o laga line si ga parallel no line singo madu no plane si bu unapam point q ase ap put hoibani point q ga magi fixed point do khangabadi distance formula palaga distance so laigani. Then any point on this line the x minus 1 by 2 ga r ga mana halabadi s value si phangani sigi y plus 2 by 3 ga r ga mana halaga x to y solve to si phange z minus 3 by minus 6 ga r ga mana halaga z ki value solve to si phange r ki particular value amana q ki point asi oigani. If the line meets the plane this then the point will satisfy the plane. Therefore, sigi twice r plus 1 as x ki from the piro y ki from the thrice r minus 2 piro z ki value dana minus 6 r plus 3 piro equal to 5. Sigi r solve to over the equation r value 1 by 7 phange masi mathak ki point as the piro the q ki point khangani. Therefore, the point of intersection of the plane and the line is r की value da 1 by 7 पिछलगा solve तौरदी 9 by 7 फंगनी r की value da 1 by 7 पिछलगा solve तौरदी minus 11 by 7 r की value da 1 by 7 पिछलगा solve तौरदी 15 by z. This is what masi kana की point of coordination of point q की coordination point ani si के अरापददी कमाइना पुथोकनी मसी सिजु खंगे distance formula पालस. The required distance, the distance between P and Q, using distance formula and solving, we gain 1 unit. Question number 11. So that A cross B, vector and cross product do expression to determinant form of where A is this and B is this. Common question, we have A cross B is this. Distributive property pansi distributive property haibadi vector anina vector amana cross toksilabadi sige property se palabadi we get A cross of B phangani atopamana asi phangani sige property loinana khoina pangadabadi I cross I 0 vector phangba I cross J haibasing to d k phangba J cross K haibadi khoina I phangba asumna magi property mayam singdo palaga putoksi A1 I cap na cross toro ani suba sida asumna plus A2 J cap na mo ani suba vector cross toro A3 plus A3 K cap na cross toro ani suba vector hojik distributive property pal amukas makata na pal sin sida purira badi sin sida cross tobagi scalar ani ga punna thangoro sin amuk sida cross tobagi scalar ani ga punna thangoro asina amok sida cross tobagi scalar ni punna thangro asuna sida puribagi we get this sina sida puribagi we get this sina sida puribagi we get this asuna phangani already sigi a3 sida puribagi suma sigi tam ahum se phangani koina khangkhre I cross I 0 vector ni perpendicular oiba ani gi dot t perpendicular oiba ani gi dot t ani ki cross ti atopa unit vector do plus or minus sign oigani sigidi 0 lerani I cross j gidi k lerani I cross k gidi minus j legani j cross I gidi sidi anticyclic oirabani na minus k lerani j cross j di 0 lerani j cross k di alphabetical order lakpani na I cap lerani k cross I gidi minus j lerani I k cross I gidi j legani k cross j gidi minus I lerani k cross k gidi 0 lerani vector sing asi 0 vector dimang karo aduna I yawa vector sing kamal laro j yawa tam ani ama lerangmani madu su minus j kamal lokto k yawa tam ani gisu k lokto. This is the expansion of a determinant. The determinant is this. Asi determinant bisi determinant si expansion ni kamjam bayai ahan basina I cap j cap k cap ni ani su basina a gi unit vector sing a1 a2 a3 ni aduga ahum suba row asina ani suba vector gi b1 b2 b3 ni. Question number 12. Find the area between two parabolas x square equal to y and y square equal to x. 4 marks. Parabola ani sigi marakta leiba jaga adugi area du integration na putu haibane. The for point of intersection parabola ani sigi kangna pongi coordination da ahan beda khangdona bhona si ani suba asida icon square karabadi y square karabadi y ko polare x square do mamang da lehori ba y no sindo khrabadi we get this tamani se factorize to asi factorize to already ahan y 0 ama legani sige y minus 1 factorize taro matung da y value 1 legani oitopya ba real value di ani si factani when y is 0 y is 0 or the x is 0 ni when y is 1 sidra sidama sinjalo y value is 1 or the x value is 1 as in this picture x square equal to y have a parabola si origin power parabola ni mahak asidi upward ta origin power y axis na tangkai khayo popot oigani maram di x ta even power karabadi y axis na tangkai khayo kan similarly y square equal to x or badi y de even power karabadi mahak asi origin ki coordinate satisfy to origin vertex na origin da laigani adu y square da even or badi x axis na tangkai ta na khayo kani lon and right water open laigani uji parabola ni sigi shaded region na sina puro kada area adoni babani origin 0 0 da amakaknare p hariba point whose coordinates are 1 1. Therefore points of intersection are origin na sina 0 0 lare p sina 1 1 lare. therefore require area the area of the shaded region asigi area si karamna putokani let us see area si y axis ta semba yai formula ani leigani sigi cup asigi mathaki cup asina sida semba area asidagi sigi makha sigi cup sina sida semiba area se khaido kharabudi area se khaido kharabudi area between them sigi area se formula sigi area se formula ani koi khange. Therefore, mathaki capacity y की value solve to y की value solve to y की value root over x लाने makha की capacity y की value solve to the x पर लाने limit t सीधे किन्हें c box c की stated region है सीधे s value ranges from 0 to 1 सीधे s value 1 है सीधे s value 0 नहीं सुन चकला ही मफे s value solve कर लाकनी 0 to 1 अनि मत लाओ सीधे दी power rule पालो सिर्फ अंगे सीख integral so power rule पालो तो definitely integral दी fundamental theorem integral calculus palo we get this simplified over 1 by t square unit jaga se integration sin raga sumna puto kan. Question number 13 so that this determinant satisfies the equation this hence find a inverse hence have an atopa technique season arrow 4 plus 2 ni 6 mark ahan bada a c given a square a q ki value changani ahan bada a square putoksu a square a into a having any purina raga si fangani matrix multiplication ki rule palaga si fangai tang a cube t a into a square or a square into a ni aina a into a square thame a ki value or standard pisale a square is just above contribution are ani do multiply tara masi achoba process samani so colony therefore left hand side is silani mag a cube ki value pisalo a square value pisalo a ki value pisalo I ki value pisalo simplify tore loinamak simplify taro matung da kono zero vector phangani si zero vector ni zero vector anba part to madi lore find a inverse 7 si ki phangiba matrix equation na si ki both side ko na a inverse na multiply taro ga a puthokna bo hona si also a inverse hajik tang khuri maktagi a kamal loktho a inverse loktho for we get this a inverse putho abadi kari lere a product a bina I tarabadi ani do amana magi inverse ahan badagi inverse di ani subudani haiba a inverse ka siga purina I tarabadi a inverse to di sig ani suba matrix asi hoigani matrix equation asi hoigani a square ki value pisala a ki value pisala 3 I ki value pisala simplify to tho asi 3 no purira simplify taraga si phangai hoji a inverse to phangiba matrix equation asi dagi aikoina puthoe atopa technique sisna ra putho di mark phangoi meaning hence hairabani na फंकिबा रिजल्ट अदु सिजनरगा पुथोले. Question number 13 or using elementary transformation find the inverse of this matrix. Elementary transformation sizinaraga matrix asigi inverse putho mark taro atopa technique na putho pa yade mafam asida di particular technique to sizinagada banina piramiba matrix asi let a equal to given matrix. We have learned that a equal to I into a I ge a ga purinardi a ta have a khankre respective value a ge piche law a ge ani suba a de lengdana thamasi I ge value piche le hojik left ta lairiba matrix asi unity gi unit matrix asi tana sinsi 1 0 0 1 0 1 0 0 0 asumna si gi order da tana sinsi poina ahan bada 1 pami leijaram le adu 2 ge jaga si 0 chalange harabadi elementary transformation season asi first row da 2 no puri raga second row da ke khaidu adoga first row da 2 no puri raga third row da chinjinau kari gidama sigi new places ani si 0 0 phanana ba that is this second row new second row sikarana phangi hanagi first row da 2 no puri raga hanagi second row da hapchilaga khaidu oga phangani simadi aduga sigi new third row sidi all third row adu da 2 times so hanagi row 1 adu hapchilaga phangani asomna sis pangthoi somda ju high operation sis pangthokani e di lengdana thangani hoji 1 0 0 1 0 1 athan si 0 tana bisin si the second row de first row khaidokani sigi 3 si 0 tana bisin si third row the 3 na puriraga first row de khaidokani high operation adu somda ju pangthokani asomna si phange row 1 khatang ahan bagi oina pangthokle row 1 habidi third row asida third row new first row sikaramna phangi sigi new first row se first row se sida 2 na purira sida khaidokpa Sida 2 na puriraga sidagi khaido 2 na puriraga khaido 0 sumne sida 2 na puriraga khaido 1 dash si tare si sum lare tangdo 1 0 0 1 0 1 0 0 si 0 0 tana bisin si row 1 dagi sigi row 1 dagi row 2 row 1 dagi row 2 khaido khro row 2 dagi row 1 row 3 khaido khro row 1 dagi row 3 row 2 dagi row 3 khaido khro we get this so right su pang thokani adudi hoji si sagi left le right le ramba unit matrix to right purak left purak pangam labani na hoji matrix ani si purina raga sigi unit matrix si tarabadi e inverse to kaya ore sigi matrix si orani hence find out show that f of x equal to modulus x plus modulus of x minus 1 plus modulus of x minus 2 is continuous but not differentiable at x equal to 2. Hariba function asi 2 da continuous oi aduga 2 da differentiable oi de proof to mark taro. Here f of x is this. Continuity at x equal to 2. 2 da mahak se continuous oi de utsi manu left hand limit at 2 denoted by this. F of x is this. X, in this case, x tends to 2 minus shows that x is a number just less than 2. The 2 dagi people number, 2 dagi khachitang people number the positive oi. The mark absolutely excellent. 2 dagi khachitang people number the 1 kind of always positive whose absolute value is also x minus 1. 2 dagi khachitang people number the 2 kind of is negative whose absolute value is minus times of this number. After simplification, we get x plus 1, which is polynomial. You have to put x equal to 2 and whose limit is 3. So now, right limit at 2, so 2 plus ni, x as 2 to get something solve number ni, f of x value pisilo, modulus to pisilo, but we get this, which is 3. Left or right, come on, is a manner. F of 2 pisilo, exactly 2 pisilo simplified or 3. Value omsi manner of the thus level limit at 2, right limit at 2, and f of 2. They 3 are equal, which shows that f of x is continuous at 2. First part is over. First half is over. Next, differentiability at x equal to 2. 2 ni, aduna mana hangwa wang si sigi 2 si sida 2 oigadabane. Left hand derivative at 2 is denoted by this, whose formula is this. X 2 plus I is 2 plus I see the 2 plus I special about the safe hangani 2 plus I say the kind of I say yam people negative number ni 2 the negative number ama absolutely 2 plus I say the 2 the people number ni 2 the khatak people number absolute value di masamak tara ni adu the 1 khaido ke is positive ni adu the 2 khaido ke negative ni mag absolute value di minus times la ani f of exact 2 within the 2 special power value ni simplify taro matong I is na divide taro matong the limit 1 pangani level limit at 2 is 1 right limit and 2 is also 3. And is a manadre. And his level limit at 2 does not equal to right limit at 2. Manadre, hence f of x is not differentiable at x equal to 2. Differentiable order. Question number 15. Prove that integrand of root over x square plus a square dx with respect to dx is this. Let I equal to this integrand. We have put this into 1 dx. Integrating by parts we get first function remains unchanged integrand of 1 with respect to dx minus integrand of derivative of first function into integrand of second function with respect to dx whose integrand is x we have put this and whose derivative is 1 by of 2 root over x square plus a square into twice x we have put this whose integrand is x. This remains unchanged 2 into 2 kaktana row we get this. Sisi matak 2 kona factorize toksi expanded form the thamsi x square root makhage siga mananaba x square plus a square hapsan gare minus a square lothokare. Hozik x square plus a square makhage root over sna yelabadi we get this. Minus a square minus of minus a square plus a square mango nasni yelabadi we get this sifangani. Sisi di I ga manarani sigi standard integral lerane mahake this puri standard integral log of x plus root over x square plus a square I minus I just want to transfer to twice I similar a function similar I put okay higher with the 2 yen to I original value to the direct thamo to divide we get this 2 divide the a square makha thamasi constant of integration half cell let's say over. Question number 16. Evaluate integrand of this from minus a to a. Denominator is numerator is rationalized of numerator is standard integral the mathak the root over yaudi root over a minus x by root over a plus x ni mathak root over mangan gyadi masamang purirani mathak the purirati makhadus purirani mathak ki damakta di a minus x phangani makha ki damakta di a square minus x square amuk resolve toksi a by of this integrand ama minus x by integral ki damak si proper standard lere si standard tana vicincy sigidi sin inverse of x by a ni sigidi aikoina a square minus x square standard substitution de x da a sin theta natraga a cos theta ni a sin theta putting toro dx mathaki x ki damakta di a sin theta leirani ma ki derivative dx ki value di a cos theta d theta ni a cos theta d theta ni sigi a square duna root 2 ama songthori a ni mathaki a amaga kathana ro dudi koina 1 a ama khakle hore sin theta ki integral de cos theta ni cos theta in terms of sin the side o in terms of sin the side over this learning sin theta de kaya ga mana hui x by a ga see the x by a thamo simplify to see we get this decimal pangani and proof let thamo see the indefinite puthoba matungda indefinite to hapselakwa indefinite limit hapselakwa limit hapsele sondu thal bracket pusulani a is the sinjalaga from a value the minus a the sinjala from a value simplify to the pi a Sugum Basili assume indefinite Hana Putoga value sinjala Sisu Karigama Tama machine and Kudong Sai 16 so that the value of this is root over 2 times of pi root over of 10x root over cot x te koina karigumba variable 10x to koina karigumba variable amagi square thamani mafam asida put 10x equal to t square so that sig 10x ki derivative with respect to x t sig square x ni aru 2 t square di twice t ni x on the dt by dx on the cross to o asdagi dx to solve to rabadi sig square x na dt ti yellow ni si pangani square x to the in terms of 10 di 1 plus 10 square x ni 10x ke kaya ga mana t square 10 square s ke di t power 4 ni silerani hari ba value singa se mataki integral api ba sinjala se silerani then sigidi 1 by t na mouse ndo khrani then ds ke value da matak to to me point ds ke value si sinjala simplify to the with silerani jimasi amok thuai se matak se 1 plus 1 by t square smag integral is ni or see them plus la dita minus assume see quadratic the same karani amuksu t minus 1 by t as you have a variable amount putting to 2 in root 2 square ni athaga sima derivative loro kanda cd pura puri di u ga manarani it is standard pare 2 into 1 by root 2 ni 2 the 1 by root 2 ni the root 2 pare u by root over 2 lerani u the restant value pisilo t minus 1 by t simplify to receive phangani t square du value di 10x phang t square pha da t du gi da makta di root over 10x phangani sagi tu yaram bagi tu ma di 3 gi tu ma risteland na thame cd definite ni when a put thoi with the indefinite ni limit hapsel se left to hapsel right to third bracket and cosel ni atop bracket ko pe aroi upper limit pi by 2 na mathakta lower limit 0 na pi by 2 sinjalo x ka pi by 2 sinjalo si phangani minus 0 sinjalo di 0 du amatakana 0 ta ga simplify to robati latest the root over 2 pi the root over 2 pi do hence 17 so that the volume of the greatest cylinder which can be inscribed in a cone of height is and semi-vertical angle alpha is 4 by 27 pi ice cube 10 square alpha khwaidagi volume chawa cylinder ama height na ice oiba semi-vertical angle alpha oiba cone ama da hapa matamda magi volume ase si oigani utlu haibani cold cylinder hapa cylinder dugi maximum volume leiba cold dugi cylinder dugi volume si oigani ullo haibani let x is be the radius of inscribe cylinder, height of coal and volume of the cylinder. Hariba letters sing asina respective parts adu khangnarasi as in this picture. Coal sigi manungda cylinder se hape cylinder si cone sigi semi vertical angle alpha haibani ma ke height sina ice ni happy cylinder du gi bo khwaidagi volume chawa cylinder ado si oi si ge expression si tagani ullo haibani. Then V volume of the V what stand for volume of the cylinder and cylinder ki pi r square into h ni pi al maha ke r d radius to x log se le aduga maha ke height ki pulak a dagina e pabu a dagina e pabu ki awang basi e dagina cylinder si coal si awang basi h ni si ki h dagi si ki kano se log thok khadi si log thok khadi si ki cylinder ki awang basi phang cylinder awang basi. There is a ice IVCD a ice have current of Putoibano right angle Magisi angle Sakanga hypotenuse Niji perpendicular ni adu Ivata di Sigi ice to the this by this. Sigi S Kamane. See the base star perpendicular yellow di Sigi angle Sigi called alpha Kamane. Trigonometry Panzele. Matanga a ice value to x called alpha Pishilo. Expand in terms of x the now b is function of x because alpha and x are given, only x is unknown. Then x squared twice later see the x cube with the later ni among to see second order loxola receive fangani second order. For maxima or minima dv by dx to put 0 the putting torani 0 the putting to factorize toro x ki value do 2 by 3 is 10 alpha oirani. When x is this 2 by 3 is 10 alpha, then second the value of second order is this, which is automatic which is minus twice by is less than 0, which is always negative number. Thus the volume of the cylinder is maximum when x equal to 2 by 3 is 10 alpha, and the height of the cylinder is is minus 2 by 3 times of is 10 alpha or alpha sigi value sing to pisalakoni by is by 3 lare. Hence the maximum volume of the cylinder is cylinder ki maximum volume the sida kone respective value the pisalani sida wena pisalasi by x ki value the 2 by 3 is 10 alpha whole square and x value la s value the pisala code alpha la code ka tenga ka thana cross simplify toro ka si phangani 4 by 27 pi x cube 10 square alpha. Question 18. A dealer wishes to purchase a number of fans and sewing machines. Lalon manipa amak na fan amasung sewing machine kaya marum leige haina ninglami. He has only rupees 5,760 to invest. Mahaki Ladiba Paisa season abong Paisa Selisima started Humpu Kaktane has space for at most 20 items. Item Kun Kaktang Mahaki Tamnana Bazaga lay. A fan and a sewing machine cost rupees 360 and rupees 240 respectively. Fan Amagina Lopatsa Puni sewing machine Amagimamana 240 Nimatang Sina. He can sell a fan at a profit of rupees 22 and a sewing machine at a profit of rupees 18. Mahakna fail Amasilupa Konitui Tongi Yonbada, sewing machine Amanalupa Trimpan Tongi. Assuming that he can send all the items that he buys, Mahakna Ladu Potpudima Yoli Haina Laura Kalaga. How should he invest his money in order to maximize his profit? Sendong Chauna Pangnana Bagidama Paisadu Maung Karamna Thadagadagi. Formulate this as LPP. Lina programming problem asi equation semo and solve it graphically yeklaga solve to. Ahanbada identify the decision variables karama quantity no khwaidagi ehana khangma mathau tari se fan amasung sewing machine leigidaba masing sing asibuni aikoina x amasung y na khangna si let x and y be the number of fans and sewing machines to purchase. Then the problem is to maximize z equal to lupa konitoi sewing machine Felamada lupa konitoi tongi adugumba x 22 x ni sewing machine amada lupa 18 tongi adugumba y 18 y ni item anidagi phangapa atongba paisa sibuni ma ki maximum profit haribasi subject to the constraints kari sumangadaba no hari item sing asigi cost price lai ma ki season nagadaba paisa gi limitation haibadi henbe yadaba magi paisa lay haribasing si less than chumani. After simplify, we get the simplest form of thame. Then x plus y should be less than or equal to 20. 20 item power magi space thamnanable layaba. Adudagi hantabasu thamba yayaba. Loinana and xy should be greater than equal. Fail masing animak fail amasing swing masing masing se negative or be yati. I have a condition sing as a seme graph exe. The graphs of the corresponding equations ahan bagi c equal to on to from both equation kawe masi poti aina both side to divide or karigidama straight line asi intercept from the thamana graph if the point you know 40 and nakane yellow c phange x by a plus y by b equal to 1 have a form jima phange mathangi asisu ma ke corresponding equation equal to on to thamo 20 in both side yellow we get this mathangi di x equal to 0 y equal to 0 are the lines ahan bagi equal line do na ab called c ka mathang sina ab haribedo sida 16 24 chal sida 16 chalaga laiba point asibuna origin dagi 16 chale sigi point na a torosi aduga sida I24 lerme origin dagi 24 ka thala aduna b torosi ani si samjinaraga kon sigi line se phang equation asidudi sini sigi equation asidi sini madu kon asida manak napa sada thangera next 2020 ni origin dagi 20 salo 16 tele decided 20 lerani origin 24 di filang kumani sigi point ani si samjinaraga lai asini equation da c lines will represent equation da soidara ma thamo hojiki one di chita thame equation sing asi chuman ba half plane sing adudi c bu chuman bari origin gi nakan sing jena chumalle sigi su origin gi nakan sing asina chumalle adudi jaga ani makta chumba jaga haragadi adigi mo x equal to 0 hadi y axis ni y axis ki right le ba point adisi y equal to 0 hadi upward jaga sina comparison ore serial region sina comparison ore comparison di originally hana sima o tholore sima a thongare sima p thonjelo sima d thongare adu sigi jaga sini koina physical region harisi point p acidi equation is solve tora babani kana component me solve tora matung da I12 phai next continue. The shaded region OAPD with vertices origin to the 0 0 or A to the 16 0 or P line and to solve equation is solved toraga I12 phangore D to the graph F to the Yahore 0 20 is the physical region. Hariba vertex singa sida max Z ki value putokani at O the Z ki value the matakale ho Z ki value the sinjala 0 8 A asida leba 16 0 X 16 Y 0 sinjala we get this. Asumna 8p the su I12 sinjala 392 the point ahumaki ha sita z ki value sing loina putok matanda aikoi problem di maximize ni value mari siman the khwai sawri silare. Thus maximum profit is rupees 392 when number of fans is in that case the I ni number of swimming machines na 12 ni. This is the correct answer. Question number 19. An insurance company insured 2,000 scooter drivers, 4,000 car drivers, and 6,000 truck drivers. Insurance company amana insurance yahon basing the scooter driver the 2,000 ni, car driver the 4,000 ni, truck drivers the 6,000 ni. The probability of an accident involving a scooter driver, a car driver, and a truck driver is 0.01, 0.03, 0.15 respectively. Hariba driver sing asigi accident thokya bagi chance asi scooter gina driver amagina 0.01 aduga car driver amagina 0.03 ni truck driver amagina 0.15 ni mathang sitna. One of the insured person meets with an accident. Karigumba insurance yauba kangbu mi ama accident thokle. What is the probability that he is a scooter driver? Mahak scooter driver oirangani haibagi probability kayano. Wow. Zik yengsi hariba makoi khudumaki accident thokpagi chance sing so amta manade aduga insurance yauba mi gi masing asi so amta manade aduna koina probability kakang yang haibasu ade masing yang haibasu ade animak si susinana hogi ko yengse. Let I1, I2, I3 be the events of selecting an insured person from scooter, car, and truck drivers. I1 sina insurance yauba mi singi manung dagi scooter driver ama khanbagi event to LSC ice to na car driver ama khanbagi aduga truck driver ama khanbagi duna ice tina matang sina lawrasi. Let A be the event that an insured person meets with an accident. A asina insurance yaw mi ama accident to A haibagi event to khangnarasi. Then P of H1 apunba insurance yaw masingli 2000 4000 6000 12000 sige manungda insurance person amar khangatpada car driver oigani scooter driver oigani 2000 by 12 ni kathana si phangani matang chena P of H2 P of H3 putore. Next, P of A by H1 probability that and A by H1 haibadi scooter yawa mi ama accident thokpagi 0.01 lere mahakina 0.03 lere 0.15 lere. The required probability P of H1 by A ni base theorem pan kadari base theorem. What is the probability he is a scooter? Karigumba mi ama insurance yawa mi ama accident to A mahak adu scooter driver ni haibagi probability P of H1 by A ni. Base theorem na di mahaki value do si lerani event ahum laigani mutually exclusive and exhaustive event ahum si lerani. Respective value pisilla simplify to ani simplify to kona sumba 1 by 52 lare adu orabadi scooter driver ama kanagumba insurance yawa ma accident to have a madu scooter driver oigani have 1 by 52 aduki matik name mi have. Question number 19. Oh, find the probability distribution of the number of white balls drawn in a random draw of 3 balls without replacement from a bag containing 4 white balls and 6 red balls. White ball mari, red ball taruk yauba bag amadagi ball ahum without replacement laukalaga hapsin dabida ahum laukalaga hapsin dabida. Find the probability distribution of the number of white balls drawn in a random draw of 3 balls without replacement. Madugi probability distribution putu number of white balls drawn machu anini yauribasi. Also find the mean and the variance of the distribution. Let's see. Let x denote the number of white balls drawn in 3 draws. Ahumlak ball ahumlak laukhatada phangba white ball gi masing du x na khangnadasi. White ball di taruk ni ahu lokot kadribadi ahumlak ni ahama lokot pusu white obeya any su lokot pusu white ball obeya ahum su white ball obeya ahuma white ball anira white ball amola white ball natabasu obeya red ball obesya. Then f can take 0 x na 0 obeya white ball amata lokotaba suno lokot red ngata lokot marino ahuma sumna white ball amakang lokot pani lokot ahum lokot. Then p of x equal to 0 haibani karina x ki biro white bone 0 lokot by the red bone ahama locally red bone adu the red bone ama ahama lokot 6 by 10 ball without replacement in hapsin the ball tarale rambada ama lokokra badi ball mapana nga hore red ball taruk yaw pada red bone ama ahama da lokari red bone mangada nga hori mathang amuk lokat pada red ball lokat pa hairaga di 5 by 9 gani asumna ball mapan yaram badagi angang amaga ani suguna lokokari ball nipan tanga hore madu red balls marini mathang ahum subada red ball ama lokatpagi probably forba aini pulapuna si phange madu bani r hai ahan bani suba ahum subata red ngata lokatpagi tani f equal to 1 hairaga di sigi taranda legani white to 100 taranda be red ani ama white to ani suba taranda red na ahan bani so ahum suba hariba cases mutually exclusive events singche akhoi di ahum lak thokani aduna masi 3 times hape aina ahan badana red la ahan badana white lokat pa red ahan ba cases to sini mutually independent cases to ahum legane ha sumna red ball white ball ani lokat pani white ball is first second third asi hariba cases lu bi ahum lokat white ball ngaka lokat to si orani hariba sing sigi table ama chembadu bani probability distribution hariba si s ki value 0 1 2 3 respective probability na kan lerani dore ahan part ki also find the mean and the variance mean haibadu di formula panjalase calculation of mean and variance table to call xi ki column pi ki column p1 pi xi ki column silerani si value si putho putho matungda mean haibadi summation of pi xi ni pi xi ki summation ni pi xi ki summation ni 1.2 lare sini milare variance the summation of pi xi square minus mean gi square sigi value di koina 2 phangre sigi value di 1.2 le square le thokro 2 gi 1.44 khaido kar di 0.56 pang sini variance. Find the principal value of this. Sigi principal value puthu have sin inverse of minus half. Sine inverse of minus half t minus 30 minus pi by 6 minus pi by 6 CD negative number lairabanina CD second quadrant change cos inverse kidi minus pi de 0 dagina pi phone second quadrant changabadi mahakidi 5 pi by 6 lairani simplify toro 3 pi by 2 lairani. What is the value of sine inverse x plus cos inverse x, which is mahakdi formula ni, that is pi by 2 ni. Define an odd function. A function f from a to b is said to be an odd function if f of x equal to minus of f of x for all x belongs to a. और function की definition से ला ले. Define an odd function. A function f from a to b is said to be an odd function if f of minus x equal to minus of f of x for all x belongs to a. The odd function की definition. One more. Let f equal to this, z equal to this. Find golf. Golf is what? Golf is 1 of 5 ta 5 na ita 1 ga ita pair ama 2 na 6 ta 6 9 na 2 ga 9 ga pair ama 3 na 4 da 4 na 7 da 3 ga 7 ga pair ama. Solution we have f of 1 is 5, f of 1 is 5, 1 of 5 ta make to f of 2 na sila da sumna g of 4 have this 7 ni sumna sila ani function na si golf ni f की domain 1 2 3 na ma की domain agani 4 5 से 1 2 3 na domain orani ma की 7 8 9 china 4 domain range orani the f of 1 is 7 golf of x is g of f of x ni kuma paladi f of 1 biselo we get this matang f of 1 di kaya ga mana hore 5 g of 5 di kana ga mana hore I ado 1 ga I ka pair sense asun matang su khot ya ga. At what point of the curve does the tangent makes an angle of 45 degree with x-axis? Curve asigi karamba point da chingba tangent na x-axis da 45 degree sembadagi. Adudi slope puthokani. Here curve asidagi koina dy by dx derivative with respect to f dy by dx puthoe we get this. This is the slope of the tangent at any point to the curve. Then also we know that dy by dx di tan theta ga manai tan theta di 45 x below kaya lere 1 lere. X to 1 bisul di y value su y equals half and point put y bane adudi 1 half. The required point is 1 half already. 25. Write the condition of perpendicularity of the two lines with direction cosine descending. Direction cosine china uneasy over line give perpendicular condition. We have learned that the condition of perpendicularity is L1 L2 plus M1 M2 plus N1 N2 equals 0. For a binomial distribution q plus p whole to the power n p plus q equals to 1, what is the variance? The variance is npq. This is the standard reason. State fundamental theorem of integral calculus. If a capital F of x is an integral of a continuous function fx defined on the interval closed interval ab, then integrand of f of x dx from a to b equal to f of b minus f of a. So R20R, what are the direction ratios of the line given by this equation? Equation C direction ratios kaya no? The direction ratios of the line given are 1 minus 2 4. Makagi number C direction ratios for. What is the condition of perpendicularity of two non-zero vectors A vector and B vector? Ani ke perpendicularity condition kari no, their dot must be 0. The condition is A vector dot B vector equal to 0. 30. The order and degree of the differential equation these are respectively. Piramiba differential equations order amasung degree ni. Hauzik root over gumba fractional power sing derivative sung yaure manghal laba matung the lepani. Sigi root over c exponent of half ni. Half of 1 by 6 ka both sides 6 na cube cancel laba di. 6 cube cancel laba sigi na 3 lerani 6 na sigi 1 by 3 into 62 lerani. Derivative sing the fractional power like hauzikti order derive order the second degree is 2. The answer is D. The range of cos inverse x principal value branch is pyramid bar cos inverse x की range पुथु उ हाई बने range to this महा की 0 to pi 0 to pi equation B ऐसी और The radius of a spherical balloon is increasing at the rate of 10 centimeter per second. At what rate is the surface area of the balloon increasing when the radius is 15 centimeter? That is solved. B. dr by dt radius hengalakpa matang radius 10 centimeter per second hengatpana plus taigani value da and mahaki surface area 4 pi r square ni maram spherical balloon neba magi surface area cd. And then ds by dt ni derivative or respective value simplification when r value 15 centimeter ds by dt is what will be I into r value the 15 in dr by dt the 6 layer 10 layer 1200 pi or any correct option D. B. 33. A value of this differential equation is integrand of a to the power x dx is a to the power f divided by log x. Option C. The angle between these two planes is two planes के angle D चुमनी सिगे formula से पार लबदी सिगे 1 का सिगे 1 का सिगे 1 का सिगे 2 का सिगे minus 1 का सिगे समाप्त और 0 लरे 0 दी cos 0 cos 90 0 ने theta 90 और option D. Which of the following functions is injective? C the linear functions in or any linear function B. Thanks for watching. Makata na series C edom matang upload tarakani miyam na miyang tabiyo.